Students, next concept related to the amino acids only, that is Zwitter ion. Very important. See carefully. Zwitter ion. Students, amino acids in presence of aqueous solution, they exist in dipolar form. What is Zwitter ion? In an aqueous solution, amino acids are exist as a dipolar ion. Take general example, amino acid RCH NH2 COOH. In presence of aqueous solution, it changes to RCH, here NH3 plus and COO minus. See here COH means carboxylic acid group, it lost the proton, and amino group, it accepts the proton. Therefore, it contains positive sign as well as negative sign, therefore it acts as a dipolar ion, also called as Zwitter ion. So definition point, this is very important. What is Zwitter ion? In an aqueous solution, amino acids are exist as a dipolar ion, self called Zwitter ion. Next, some note points related to this Zwitter ion. See carefully. If you take an example, glycine. You know the structure of glycine, that is HCH NH2 COOH. In presence of aqueous solution, it changes to HCH NH3 plus COO minus. This is the Zwitter ion structure of glycine. Similarly, if you take an example, alanine. How you write the structure of alanine? See here. This is CH NH2 COOH. In presence of aqueous solution, it changes to CH3 CH NH3 plus COO minus. This is the Zwitter ion structure of alanine. This is very important. Please remember the Zwitter ion structure of alanine. Next, students, you know, among those 20 amino acids, your glycine. This glycine only, it is one of the optically inactive amino acids, but others are optically active amino acids. What are the evidence which shows the compound should be optically active? Mainly there are two conditions. See here. Conditions to show the optical activity of the compounds. What are those? In that, my first point, they must contain asymmetric carbon atom. And also another point, they contain stereoisomers. What is asymmetric carbon atom? One of the carbon atom itself, it is surrounded by other atoms or group of atoms. Then it is referred as asymmetric carbon atom. You already know this concept. And another one, stereoisomers. What are stereoisomers? Compounds having same molecular formula, and there is a differ in the special arrangement of atoms. Students, if the amino acid, if it is said to be an optically active amino acid, then must and should they possess these 2 points. Means it must contain a symmetric carbon atom and also they contain stereoisomers. But when you come to the concept of glycine, it do not contain a symmetric carbon atom and it also do not contain any stereoisomers. Because of these points, glycine is one of the optically inactive amino acid. Please remember this point. This is very important. And another one very important concept related to Zwitter ion. In presence of Zwitter ion, amino acids shows amphoteric nature. Remember this point. In presence of Zwitter ion, amino acids shows amphoteric nature. Means it acts as both acid as well as base. If you take an example, see here general structure of amino acid write like this: CH, NH2, COOH. Sorry, general formula of Zwitter ion is like this. Okay, if you increase the acidic concentration, means H plus, if you increase the acidic concentration, at the time it changes to R, CH, here NH3 plus, and instead of COO minus I write COOH. Means this is the Zwitter ion. And if you increase the concentration, means acidic concentration, at that time it becomes a cation because it contains here positive charge. If you increase the basic concentration, means add OH minus here, at the time it changes to, means our Zwitter ion changes to RCH. Here I write only CO minus, but instead of NH3 I write NH2. Here NH3 plus, here NH2. Okay, it contains negative charge, therefore it is referred as anion. Because of this point, in presence of Zwitter ion, our amino acids act as a amphoteric substance because it is also act as both acid and base. One very important note here related to this concept, please remember, at lower pH amino acids move towards cathode. At lower pH, amino acids move towards cathode, and higher pH amino acids move towards anode. This is very important point. It also helps for your CET as well as NEET level examination. Remember this point. At lower pH, amino acids move towards cathode, and at higher pH, amino acids move towards anode. Okay. If you know this concept well, or remembering this concept, at lower pH amino acids move towards cathode and higher pH amino acids move towards anode, then you also remember one very important definition point, that is isoelectric point. Isoelectric point. This is isoelectric point. At particular pH, our amino acid, it cannot move towards either anode or cathode. That particular point is called isoelectric point. Students, in presence of lower pH value, amino acid move towards cathode, and at higher pH, amino acid move towards anode. But a particular pH, our amino acids cannot move towards either cathode or anode. That point is called isoelectric point. If you take an example, glycine, its isoelectric point is about 6.0, and alanine 6.1, etc. These are some theoretical points. Please remember, definition point. This is also very important. What is isoelectric point? At a particular pH, our amino acid cannot move towards cathode or anode. Next, about peptide bonds. Peptide bonds. Peptide bonds. When one of the amino acids, it undergo condensation with another amino acid. Condensation means removal of water molecule. When one of the amino acid, it undergo condensation with another amino acid and forms the CONH bond. CONH bond, then it is called as peptide bond. See here, I write the general formula of amino acid like this. One of the amino acid here, and it undergo condensation with another amino acid. Right, like this. NHH CHR COOH. Here condensation process takes place, therefore this water molecule is removed. At the time it becomes NH2 CHR, here CO, and this NH, and itself CHR COOH. This CONH bond is called peptide bonds. Peptide bond. Therefore, we can easily define peptide bond as when one of the amino acid, it undergo condensation with another amino acid and forms CONH bond. Note point here, the number of peptide bonds can be calculated by using formula n minus 1. What is this n? It indicates the number of amino acids. Then how many peptide bonds are present in tripeptide? Tripeptide. Tri means 3. Means here 3 amino acids are involved. Therefore, there are 2 peptide bonds present. There are 2 peptide bonds present in tripeptide. Next, what about tetrapeptide? Number of peptide bonds present in tetrapeptide is 3. Next, polypeptide bond. Polypeptide bond. Concept about the polypeptide bonds. Here, number of amino acids undergo condensation with amino acids. Here, several number of amino acids itself undergoes condensation. At that time, they form number of CONH bonds. At that time, you get the structure like this: NH, CHR, here CO, this NH, and CHR dash, here CO, and NH, CHR double dash, CO, NH, CH, etc. here one CONH group is present, here also it is present, here also it is present. These are called polypeptide bonds. Polypeptide bonds. Means here several number of amino acids undergo condensation process. At the time they form number of CONH bonds.